Welcome back. We're going to go into 1.4 equations of lines and modeling. So just a friendly reminder on your point slope equation, because we're going to use that quite a bit today. That is going to be y minus y1 equals your slope times x minus x sub 1. So we're going to find the following equations in slope-intercept form. Y equals mx plus b. But a lot of the times when we're looking for y equals mx plus b, we're going to use point slope form to get there. So just keep that in mind. On this first example, we have a slope of negative 7/9, and I have a y-intercept with this ordered pair of 0, 16. So to write this in slope-intercept form, y equals my slope of negative 7/9 times x plus my y-intercept of 16. Nice and straightforward on that one. On example B, I have a slope of negative 2/3, but now I just have a point. I have a point at negative 3/6. So we're going to use point slope form since that's what I have. All right, we're going to take y minus the y value of my ordered pair, so 6, equals my slope, negative 2/3, times x minus the x value. That's going to change it to a plus 3. X minus negative 3 changes that to a positive. Now I still need to get it y equals, so I need to distribute my slope to both of these values. So y minus 6 equals negative 2/3 x minus negative 2/3 times 3 is just going to give me a minus 2. So distributing that negative 2/3. Then to finish this off, I'm going to go ahead and add 6. So that way y is alone. That's going to leave me with y equals negative 2/3 x. Negative 2 plus 6 will give me a positive 4. And I have slope-intercept form with a point and a slope. All right, we're going to save C to do together. All right, talking horizontal and vertical lines. Okay, for horizontal lines, I'm going to try to give us a little bit of space on this one. For horizontal lines, we're going to see that as a line that looks like this versus vertical. Are going to be our vertical lines that look like this. For horizontal lines, it's always going to look like y equals a number, and vertical lines is going to be x equals a number. Horizontal lines have a slope of 0, and vertical lines have a slope that's undefined. So if we want to write equations of the horizontal and vertical lines that pass through this point right here, so let's go ahead and we'll do the horizontal here and the vertical here. So a horizontal line, remember, is going to be y equals a number, and it's just going to be that number in your ordered pair. So the y value of my ordered pair is negative 8. That's the equation. It's done. For a vertical line, we are going to have it as x equals a number. So x equals the x value of that ordered pair, negative 5, and that is done. Slopes of parallel lines. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. Reciprocal slopes. All right. In example 3, we're going to determine if these equations are parallel lines or perpendicular lines. So the first thing I want to do on all of these is I want to get them into y equals mx plus b so I can quickly find that slope, since parallel and perpendicular all depend on if the slope is the same or opposite reciprocals. So I'm going to go ahead and do this first equation in blue. If I want to get that y equals, I'm going to subtract 2 from both sides. Oops, that'll still stay a positive 5x minus 2, subtracting that over. That one is done. I'm just going to put a star next to him to know that that is done. Now I'm going to work this one in red. So I get 5y equals subtracting that x minus 15. Then divide everything by 5. Y equals negative 1/5 times x minus 3. 3. I'm going to put a little star there to know he's done. The slope of my first one is the number in front of x, so I know I have a slope of 5 for that one. Slope of my second guy, the number in front of x, negative 1/5. Now looking at these slopes, I want to know, are they exactly the same? Are they opposite reciprocals, or are they neither? Well, they're opposite. This first one is positive. This second one is negative. And so that's what opposite means, the signs. And then reciprocals, if you were to take your fraction and flip them, those would be reciprocals. Well, this first fraction would be 5/1. And if I flip that, I get 1/5. Yes, those are reciprocals. So these would be perpendicular lines. All right, example B. We're going to go ahead and do the same thing here. So I'm going to take that first equation and get it y equals mx plus b. So 2y equals subtracting that 4x plus 8, divide everything by 2. Y equals negative 2x plus 4. That's done. I'm just going to start. Second equation, I want to get y alone. So I like to put y in front. So negative y equals, I'm just going to rearrange here, positive 2x plus 5. Now I'm going to divide everything by negative 1. Y equals negative 2x minus 5. Now that guy is good. Writing my two slopes. The first slope in blue, that number in front of x, negative 2. Second slope in red, number in front of x, negative 2. Those are the exact same numbers, so we know that these are going to be parallel lines. All right, finishing it out with C. I bet you can't guess what this one's going to be. Y equals positive 2x plus 1. Star it, he's done. In red, all we need to do is subtract that 3x. So y equals negative 3x plus 4. Star it, he's done. Let's go ahead and look at these two slopes. Slope of my first guy, number in front of x, 2. Slope of my second guy, number in front of x, negative 3. These numbers are not exactly the same. They are not opposite reciprocals. They are opposite. One's positive, one's negative, but they're not reciprocals. You can't just flip that fraction. And so these would be neither parallel or perpendicular. All right, now I'm going to save those last two examples 4 and 5 to do in class with you. Thanks for watching.